Hi folks, welcome back. So a few times on this channel, I've talked about the GDP and economic impact of using AI for knowledge work. And that is why this paper caught my eye. It was also on Tyler Cowen's blog. That's how I found it. So this paper is essentially trying to empirically find scaling laws for knowledge work, for economic productivity. It's by an economist from Yale, came out just a couple of weeks ago, Christmas 2025. And the word scaling laws is, of course, a nod to the famous scaling laws paper for LLMs, which found that as you give it more data, more training time, you get better and better performance out of LLMs. And so the author here is trying to find a similar scaling law for what happens when you use more LLMs and more advanced or more recent LLMs for knowledge work, hence the term scaling law. So let me not bury the lead. Let me explain the headline findings first and then get into how they arrived at it. Each year of model progress reduced task time by 8%. So they assigned people to use different LLMs, and the ones that used more recent LLMs were able to finish tasks faster, with 56% of gains driven by increased compute and 44% by algorithmic process. So what this means is that for this faster task finishing time, more than half was driven by better training or better inference, and the other 44% by everything else. So better algorithms for training, not just raw compute. And now this is interesting. They used LLMs in two modes. One is just kind of one-shot mode where you prompt it and get a reply. And the other is as an agent where the LLM can call tools and make multiple iterations. And they found that productivity gains were much larger for the one-shot users. And that has some interesting implications. And to conclude, they did some modeling and found that continued adoption could boost US productivity by 20% over the next 10 years. On an annualized basis, that's about 1.8% per year, which is not that far off from a couple of other papers that have tried to estimate the impact of AI on GDP. I've covered some of those papers on this channel. I'll leave a link to those in the description. The setup and population for this paper is really interesting. So they have a randomized controlled trial with 500 professionals. And these professionals come from very typical knowledge work kind of lines of work like management, data analysis, consulting. So this is the bread and butter of the knowledge work economy. And it's really interesting to see the kinds of tasks that these participants were asked to do. It's spelled out in the appendix. And you'll see how common these kinds of tasks are for consulting and data science and so on. For example, this one, you've got to revise a report about whether some investment in a company or a factory makes sense. So you have to do a ton of analysis, crunch a lot of data, and come up with a recommendation and write a report. Here's another task. This is for a data analyst. Do a correlation analysis of inflation and economic growth. So there's a couple of hypotheses you're looking at, and based on how you analyze the data, you have to support or rule them out. And you have a data set of IMF countries and their economic indicators. So you see how these tasks are very typical and realistic. These aren't contrived tasks. Okay, so they got 500 people and they were given a bunch of these tasks, and they were randomly assigned either to a control group or a group that was using LLMs. And they were using a ton of them, 13 different LLMs spanning various sizes and release dates. So that's how they make correlations between task time and the release date of the LLMs being used. And what was measured was both how long they took to complete these tasks, but also how well they completed it. So the output quality was rated on a scale of 1 to 5. And then there was some measure of productivity because they were paid a fixed amount for completing a task, but they got a bonus if they received a high grade on the task. So that lets you assign some notion of pay per time. All right, so what were the main findings? Using any kind of AI at all, not even a particular model, increased the base earnings per minute by 81%. And this happened while the quality went up by 18% or zero point 0.3 standard deviations. So that's a substantial bump just for using any kind of AI at all. And if you translate this to that pay structure of $15 per task, using AI increased their total earnings per minute by 146%. So from 73 cents per minute to $1.79 per minute. Okay, now here's an interesting finding. The gains are much larger on non-agentic tasks. So what they found was for non-agentic tasks, they earned an extra 83 cents per minute. But on agentic tasks, it was only about 18 cents. So what explains this difference? The author has a hypothesis here, which is that the one-shot kind of tasks LLMs are really good at, and they're also relatively simple. As they say, rapidly commoditizing analytical cognition. But things that require what they call procedural agency, which essentially means tool use. So the LLM has to call tools to get something done. So call an API or send an email or click something on the screen. That remains more resistant to automation. And that might happen because that kind of multi-step tool use is much harder to define. It's much harder to judge whether it went well, and sometimes the harness doesn't have the right tools. So there are a number of confounding factors there that might explain this divergence. The other interesting scaling law they found was because they were using a bunch of models with different release dates, moving 1 year forward in model release date is associated with roughly an 8% reduction in time taken to complete a task. So that's a pretty nice linear relationship between how good a model is as proxied by how recently it was released and how much time it saves in doing a task. And they have similar scaling laws of model release date against earnings per minute, where as the models get better, the earnings per minute keep going up. And the other side of that is time taken to complete a task. Again, as the release date of the models increases, the time taken decreases. But note that this is a log scale, so this is log of the time taken. So that was a really interesting paper that talks about how you find these knowledge work economic scaling laws when using AI, both in terms of productivity, how quickly tasks are completed, how earnings go up, and how it kind of scales very neatly with the capabilities of the models. So yet another empirical validation of how AI really is helping knowledge work. All right, I hope you enjoyed that. If you like content like this, consider subscribing, like the video, and I will see you next time. Thank you.